Hi friends, welcome back to my YouTube channel. So today we are going to discuss Computer Communication EC 407 from Module 2 Media Access Control CSMA CD. So we have already discussed CSMA, the basics of CSMA, carrier sense multiple access and various techniques and the basic introduction for that in part 1. You can already refer that video in this same channel. I will post the link for that particular video in the description. So you can also watch that one. So let's begin the video. Like this is from module 2. This is for EC 407 computer communication and for electronics and communication engineering students BTECH. So let's start the video. So CSMA CD is carrier sense multiple access collision detection. So this is a method does not specify the procedure following a collision. So CSMA method does not specify the procedure following a collision. So collision means like whenever we are sending one frame to another, in one frame to another location, sender to receiver or something like that. So there might be a collision of these frames one to another. So we need to avoid or we need to detect that particular collision with that frames and we need to avoid that situation. So for that we have this method CSMA CD. So carrier sense multiple access with collision detection augments the algorithm to handle the collision. So this is an algorithm to identify the collision where the collision occur or the collision detection. In this method, a station monitor the medium after it sends a frame to see if this transmission was successful. So here a station monitor the medium. So a station is monitoring the medium where we are sending the frame to one sender to receiver and it will check whether the transmission was successful or not. If so, the station is finished. If, however, there is a collision, the frame is sent again. To better understand CSMA CD, let us look at the first bit transmitted by two stations involved in the collision. So if we see in the figure, so station A, B, C and D is there and T1 and T4 is the transmission time. So first we will send first bit of A to the A to D and it will go and there is a collision C is collision detection and abortion. So there happened a collision and it will abort the sending of that particular bit from A to D and this is happening in the medium. So although each station continues to send bits in a frame until it detects the collision. We show what happens as the first bit collide. In figure, station A and C are involved in the collision. So that is shown in the figure. A and C is involved in the collision. At time T1, station A has executed its persistent procedure and starts sending the bits of its frame. At time T2, station C has not yet censored the first bit sent by A. So at T2, what happened? Transmission time. So at T2 time, the bit from station A is not sensed by station C and station C execute its persistence procedure and start sending its bits in its frame, which propagates both to left to right. So the collision occurs sometime after time T2. So station C detect a collision at time T3 when it receives the first bit of A's frame. So T3 is the time when C receives the first bit of A. And at that time also after T2, T2 means T2 means C starts sending one of its bits to D and at the same after T2 after sometime after the T2 C collides a detection the detects a collision from bit A and station C immediately or after a short time but we assume immediately aborts the transmission and station A detects collision at time T4 when it receives the first bit of C's frame it also immediately aborts the transmission. So what happens here, like A sends a bit to D and C also sending a bit to D. So once A starts sending a bit to D is from T1, time T1 and C sends a its bit to D after T2 or at T2. So while sending a bit from A to D, C does not sends the bit from A. So it also start sending a bit to D at T2. So once A is detected under C, the station C, and it is acknowledged that there is a collision. Like there is a collision, like it also started sending a bit to D, and A is also sent one bit to D. So it will at the same time it will stop sending bit to D, and also station A also senses that there is a collision at time T4, and it also immediately abort the transmission. So this way we can detect the collision. So carrier sends multiple access with collision detection means this. So you can if in exam if you are asked about CSMA CD, you can directly give this figure and keep that this is the explanation, and this is a simpler explanation that I can give for this one, and figure also you can put the same, and explain it very well, then it will be better. So that is all about the CSMA CD and figure explanation. So I think you have got an idea. So looking at the figure, we see A transmit for the duration T4 minus T1, and C is transmit for a duration T2 minus T3 minus T2. So that is also shown in figure. This is the T2 minus T3, and this is the T4 minus T1. And later we show that for the protocol to work, the length of any frame divided by its bit rate in the protocol must be more than either of this duration. At time T4, the transmission of A's frame, though incomplete, is aborted. At time T3, the transmission of B's frame, though incomplete, is aborted. So now what we know, the time duration for these two transmissions, we can show more complete in a figure, complete graph in the figure. So this is shown in the figure. This figure is shown for that one. So A, B, four channels are there, four stations are there, and T1 and T4 is the transmission time, and T2 to T3 is the transmission time of C. And A detects collision and it aborts at T4, and C detects a collision and aborts at T3. So minimum frame size. So this is one of the parameter for minimum size frame. For CSMA CD to work, we need a restriction on the frame size. So before sending the last bit of a frame, the sending station must detect a collision, if any, and abort the transmission. This is so because the station, once the entire frame is sent, does not keep a copy of the frame and does not monitor the line for collision detection. So what happened here? To work the CSMA CD collision detection to work, we need to restriction the frame size. So before sending the last bit of the frame, we need to detect a collision, if any, and abort the transmission. If there is nothing like that, if there is no collision, and this is because so why we are doing that, we need to verify or confirm that once the entire frame is sent, and that station does not keep a copy of the frame and does not monitor the line for collision detection. Therefore, the frame transmission time TFR must be at least 2 times the maximum propagation time TP. So TP is maximum propagation time and TFR is the frame transmission time. To understand the reason, let us think about the worst case scenario. If the two stations involved in a collision are the maximum distance apart, the signal from the first take time TP. This is the propagation time. And to reach the second, and the effect of the collision takes after time TP. To reach the first, to reach the first. So the requirement so that the first station must still be transmitting after 2 TP. So next one is we can go through the algorithm of CSMA CD. So here you can see the figure for CSMA CD. and the station starts a frame, station has a frame to send. Okay, so it will start and k equal to 0. We are setting a variable k equal to 0 and apply one of the persistence method. And this is already we have discussed in the first video. Let's go and watch that video once you have any doubt regarding the one persistent, non-persistent and p persistent. And if it is eligible for transmission, transmission is done or collision detected. If it is yes, then it will go to collision detector part. If it is collision detected, yes, then it will goes to, I mean, if it is collision detector, no, then it is a success. If collision detector, it is yes, then send a jamming signal and k equal to k plus 1 and it will give a k max, k greater than k max. Yes, then abort. It will abort. That we already discussed in the previous slide. Like k greater than k max, then it will abort. And if it is not, choose a random number r between 0 to 2 raised to k minus 1. And then it will wait TP time. T TB time equal to R into TP or R into TRF. TP is the propagation time, TRF equal to the frame time, total sending the frame size. So we need to wait that much time and then it will goes to the first step, k equal to 0, below the k equal to 0, and it will again apply the persistence method and the flow will continues here. So that is happening here. And k is normally 15. So we have get k max is normally 15. So this is the algorithm structure. And you can directly draw this figure and explain it and you will get a maximum score, I think. So now let us look at the flow diagram. So I will give an exact overview of that one. We need to sense the channel before sending. Before we start sending the frame by using one of the persistence process we discussed previously, non-persistent, non-persistent, and p-persistent. The corresponding box can be replaced by one of the persistent process shown before. The second difference is the frame transmission. We do not send the entire frame and then look for a collision. The station transmits and receives continuously and simultaneously using two different ports. We use a loop to show that transmission is a continuous process. That's why this part, it is a continuous loop. If there is a detection, then it will go to the no part, and if there is no detection, then it will goes to yes part, something like that. So we constantly monitor in order to detect one of two conditions: either transmission is finished or a collision is detected. Either event stops transmission. When we come out of the loop, if a collision has not detected, it means that transmission is incomplete. The entire frame is transmitted. Otherwise, a collision has occurred. The third difference is the sending of a short jamming signal that enforces a collision in case other stations have not yet sensed the collision. Energy level. Energy level means we can say that the energy level in a channel can have three values: 0, normal, and abnormal. At 0 level, the channel is ideal. At normal level, a channel has successfully captured the channel and is sending its frame. At abnormal level, there is a collision and the level of energy is twice the normal level. A station that has a frame to send or sending a frame needs to monitor the energy level to determine if the channel is ideal, busy, or in collision mode. Figure shows the situation. Energy level and time. Frame transmission in time, it is 0. And in ideal, the collision, it's there. And frame transmission, this is the figure showing energy levels. And throughput means the maximum throughput occurs at different value of G is based on persistence method and the value of P in P persistent approach. For one persistent method, the maximum throughput is around 50% when G equal to 1. For non-persistent method, the maximum throughput can go up to 90% when G is between 3 and 8. So that is all about CSMA CD. So two things we have discussed. The main thing is that the algorithm part, and algorithm is very clear from the figure itself. And the first thing is the main part, how we are detecting the collisions in the frame sending the bits of a frame. And this is also important. You can go through this video and you will get an overall idea of CSMA CD. In next video, we will discuss about CSMA CA, career sense multiple access, our career collision avoidance. So we need to avoid the collision. So we are using that method CSMA CA. So that is all about today's section. So we will continue the other part in the next video. So thank you for watching my video. If you like this video, please subscribe my channel, like, share and comment. See you in the next video.